On our tour, we will be sitting in on Professor McGonagall's conceptual physics class. Today, they will be exploring the magical world of momentum. Let's go!
Hello, I'm wearing Muggle clothing because we just finished Muggle studies. Now we're moving on to momentum, so you're just in time. Let's get started. Momentum is inertia in motion, also known as P equals mv, or momentum equals mass times velocity. The momentum of something in motion can be increased by increasing the object's mass, velocity, or both mass and velocity.
Professor?
Yes, Ron?
I was wondering if you could tell us an example of momentum.
I would rather have Draco answer that question, please.
An example of momentum is like if a troll runs into a wall, what the mass of the troll is and the velocity, so like how fast it was going and in what direction.
Very good, Draco.
Professor McGonagall?
Yes, Harry?
So, if a troll and a goblin were both running at the same speed, which one of them would have a greater momentum?
The troll, because it has a greater mass.
Oh, because momentum is mass times velocity. So if you increase the mass, then it has a greater momentum.
Yes, very good, Harry. Law of conservation of momentum. If a group of bodies are exerting force on each other, their total momentum remains conserved before and after the interaction, as long as there is no external force acting. Draco, please pay attention. Do you have any questions?
Yes, since my father just bought me this new Nimbus 2001, I was wondering how could I apply these momentum problems to improve my Quidditch game.
Now we're moving on to our next topic, which is impulse. Class, does anyone know what impulse is? Mr. Weasley.
An impulse is a change in momentum.
Very good, that is correct. To get impulse, we use the formulas force times time or mass times change in velocity.
Professor McGonagall, I have a question. I know because I'm a seeker in Quidditch, but actually I'm going to be captain of our team this year. And I was wondering what I should tell my players. So if they were to hit the bludger with their bat and follow through and keep the contact time twice as long as they usually would, how much would the momentum of the ball and the impulse of the ball increase?
Good question, Harry. By doubling the impact time between the bludger and the bat, you are doubling the change in momentum, thus the impulse. Yes, Mr. Weasley?
Why do Muggle cars have airbags then?
Draco, wake up. Answer Mr. Weasley's question.
Because Muggles are idiots. No, it's because they don't have impediment charms that slow it down. So they need to have the airbag as a buffer so that it lowers the momentum when they hit the car and the impact time.
Let's review. Momentum review problem. Calculate the momentum value of a 4-kilogram rock moving through the air at 20 meters per second. Steps to solve. Momentum equals mass times velocity. Thus, momentum equals 4 times 20. So, your momentum will equal 80 kilograms times meter per second. Impulse review problem. Calculate the impulse experienced by a 5-kilogram ball encountering a force of 115 newtons per 2 seconds. Steps to solve. 1. Impulse equals the mass times the change in velocity, or force times time. Substitute 115 and 2 for your impulse times time. So you get 230 newtons per second. This is what happens when Quidditch players use impact and they don't give with their hands to increase the time of impact. Ouch! And this is what happens when they give with their hands to increase the impact time.